Good morning, dear students. Welcome to the class of Dynamics of Machine. Today's topic is gyroscopic couple on airplane, and in this we are going to see the third numerical of airplane. Before that, we will learn the course outcome of the course. The students will be able to estimate the effect of gyroscopic couple on airplane, and the program outcomes or the learning outcomes are to understand the gyroscopic effect and the industrial application of gyroscope. Let's have a quick revision of the previous topic. We have studied the gyroscopic effect on airplane, and we have solved two numericals of gyroscopic couple on airplane. Let us have the question number 3. The rotor of a turbojet engine has mass of 200 kg and a radius of gyration 25 cm. The engine rotates at a speed of 10,000 rpm in a clockwise direction if viewed from the front of the airplane. The plane, while flying at 1000 km per hour, turns with a radius of 2 km to the right. Compute the gyroscopic moment the rotor exerts on the airplane structure. Also determine whether the nose of the plane tends to rise or fall when the plane turns. Let's go to the solution. We have the given parameters m equals to 200 kg, radius of turning is 2 km, that is 2 meter, velocity as 1000 km per hour. We will convert this velocity in meters per second, and it comes to 277.77 meters per second. The radius of gyration k is given as 25 centimeter, which is 0.25 meter. The angular velocity n is 10,000 rpm clockwise. So we will convert this angular velocity n in terms of omega, and the formula for that is 2 pi n upon 60, that is 2 into 3.14 into 10,000 divided by 60. So the angular velocity omega comes to be 1046.66 radians per second. Now the three conditions are given. We are viewing the plane from the front end. The turning of the plane is on right side and the engine rotation is on clockwise. And we have to find out the gyroscopic couple C with its effect. Let us see. We know that the gyroscopic couple equation is given by C equals to I into omega p. Now the first term is I, and equation for I is I equals to m into k square. So we are having the value of m as 200 and k as 0.25. So the value of I comes to be 12.5 kg meter square, and angular velocity of precision is given by the equation omega p equals to v upon r, where v is the velocity and r is the radius of turning. So omega p equals to 277.77 divided by 2. So the value of omega p comes to be 138.88 radians per second. Therefore our equation becomes C is equals to I into omega p. So the value of I is 12.5, omega is 1046.66, and omega p is 138.88. So the value of C comes to be 1.81 into 10 to the power 6 Newton meter. Now we will see the conditions. We are having the three conditions, that is viewing from the front end, turning is on right side, engine rotation is on clockwise. So with respect to these three conditions, the effect of gyroscopic couple is when the aeroplane turns towards right, the effect of gyroscopic couple is to lift nose upward and tail downward. Let us see once again. We have the three conditions, that is, we are observing the plane from front end, the plane takes a right turn, and the engine rotates in a clockwise direction. So, the effect of gyroscopic couple is to lift nose upward and tail downward. You can see in the diagram also, the front part of the plane is going up and the rear part is going to down. We have covered the following program outcomes, that is, basic knowledge, experimentation and practices, the engineers and the society, and lifelong learning. Following are the assignments which we have to solve. You have to answer the questions which are available on the below link, and in our next topic we will learn the gyroscopic couple on four-wheel drive. Thank you.